Next, we will discuss about equivalence of mechanical work and heat. Equivalence of mechanical work and heat. Let's take an example. We have a gas at temperature T is equal to 100 degrees Celsius. When we compress this gas, its temperature becomes 200 degrees Celsius. We know by compression the temperature increases. So by compression we have increased the temperature of the gas from 100 degrees Celsius to 200 degrees Celsius. We can do the same by giving some heat to the system. Suppose the gas has temperature is equal to 100 degrees Celsius. We have given heat, so its temperature reaches to 200 degrees Celsius. So we can say that we can reach to T is equal to 100 degrees Celsius by doing some work or by giving heat. So work and heat both are equivalent in this sense. We can say work is directly proportional to heat. We can say W is directly proportional to Q, or W is equal to JQ. J is joule mechanical equivalent. Work is equal to JQ, and J will become W upon Q. Here J is joule mechanical equivalent of heat. Next, we will discuss zeroth law of thermodynamics. According to zeroth law of thermodynamics, when two bodies B and C are in thermal equilibrium with each other, and B is also in thermal equilibrium with A, then A is also in thermal equilibrium with C. Or we can say, when two bodies are in thermal equilibrium with each other and independently to another body, then the three bodies are all in thermal equilibrium with each other. That states that the two systems are in thermal equilibrium with the third system. They also in the thermal equilibrium with each other. Means B is thermal equilibrium with A, C is thermal equilibrium with E, then B and C will also be in thermal equilibrium. Then we will discuss the first law of thermodynamics. The first law of thermodynamics is actually based on conservation of energy. That means energy can neither be created nor be destroyed. It can only be transferred from one state to another. Or it can be transformed from one form to another. According to first law of thermodynamics, there are certain statements which we deduce from the first law of thermodynamics. First is the total energy of an isolated system remains constant unless until we have done some work on it or we have given some heat to the system. The second generalization is whenever we have given some amount of energy, the equivalent amount of work will be done by the system. जब हम सिस्टम को हीट देंगे या एनर्जी देंगे तो वो कुछ ना कुछ आगे से उसके बदले में काम करेगा. This is according to the first law of thermodynamics. And third is, it is impossible to construct a machine which gives us energy without consuming anything. So this kind of machine cannot be possible, which does not consume energy and gives us energy continuously. It is not possible. So in general, when it comes to mathematical equation for the first law of thermodynamics is equal to delta U is equal to Q plus W. Delta U is equal to Q plus W. Delta U here is change in internal energy. The internal energy of the system can only be changed by giving some heat or by doing some work or by doing both. या फिर हम दोनों करें या फिर हम एक भी करते हैं तब भी हमारा क्या होगा, इंटरनल एनर्जी चेंज हो जाएगी. So according to first law of thermodynamics, what is work? Work is actually pressure into change in volume. So dW will be equal to P delta V, yeah, P dV. So du is equal to dQ minus P dV. Energy change with volume and heat. So now we can integrate du is equal to dQ minus P dV. When we integrate it, it gives us U2 minus U1, means total change in internal energy will be equal to total change in heat minus total work done, and that is Q2 minus Q1 minus PV2 minus PV1. At constant pressure, we can say the Q2 minus Q1 will be equal to QP, and it will become U2 plus PV2 minus U1 plus minus PV1. QP is measurable by measuring the temperature changes resulting from the energy changes of the. When the change in volume is constant, means the volume is constant, delta V becomes 0, then this Q2 minus Q1 becomes QV. The heat change at constant volume. The heat change at constant volume, and delta U becomes equal to QV only. Internal energy U, du or delta U are positive if energy of the system increases. Heat, if we give heat, then it is added. Work done on the system is also positive, and work done by the system is negative. Then there is another term comes, that is enthalpy. We have seen in the previous slide that QP or delta U is equal to Q2 minus Q1 minus PV2 V1 minus V1. QP is equal to E2 plus PV2 minus E1 minus PV1. So we can see here H is equal to U plus PV. By differentiating this, we get TH is equal to du plus PdV and plus VdP. H1 becomes U1 minus PV1 and H2 becomes U2 minus PV2. Delta H will be equal to H2 minus H1, which is equal to QP.